Hello, everybody. Welcome again to the part two of this two-series webinar around the 7 tough questions to ask your load balancer vendor. Hopefully, you enjoyed our the first episode of this, where we covered the first 4 questions, and today we're going to go over the 3 other questions around. What are some of these questions you should be asking your load balancer vendor? My name is Didi. I head up marketing for Avi Networks, and joining me today is a subject matter expert, Ashish Shah. Ashish, you want to say hello?
Good morning, everyone. Hi, Didi. Thank you for having me.
So a quick recap, folks, of why we're talking about these 7 new tough questions. At the highest level, the way we deploy applications, design applications, and the way we access applications has fundamentally changed over the last 5 to 10 years, where more and more apps are now on cloud-like infrastructures. The applications themselves are more of microservices-based architectures as opposed to monolithic applications. And as we all know, mobile is going to become the predominant access method of accessing these applications. So in this new landscape, what is needed is a complete rethink of how application delivery has to happen. And so the specific appliances that we're talking about today are application delivery controllers, which is a fancy name for what we've always called as load balancers. Like I mentioned, this is a 2-part series. So we covered the first 4 areas around self-service provisioning, elastic scale, complete software-based solutions, and the integrated application visibility in part 1 of this webinar. And then today we're going to take a closer look at 3 other questions around security, multi-tenancy, and automation and integration. So before we get started, here's another quick recap about Avi Networks. We've been around as a company for a little over 3 years. We've got about 25 customers, predominantly Fortune 500 customers, but we do have quite a few smaller deployments as well. What we've built is a next-generation application delivery controller with integrated analytics. And this chart also shows you some of our top customers. We're deployed at a top 3 US cable provider. We're deployed at a top 5 financial services institution in, out of the New York area. Unfortunately, the red tape in some of these organizations has not allowed us to call them out specifically. But it should just give you an idea about how well the company has done since its inception a little over 3 years ago. Where we see strategic differentiation when we talk to some of our customers, these are the 3 things that they like about our solution. First off, it's a distributed architecture. So as opposed to monolithic ADCs or load balancers, what we've built is the world's truly distributed architecture-based application delivery controller, where you have the micro load balancers at different locations, but they can all be managed from a single point because of our architecture can be managed from the Avi controller. We're also the first ADC vendor that does integrated inline analytics, which combines deep visibility about users, compute, applications into and uses that real-time information to impact the load balancing algorithms itself. And then last but not least, our pricing model is also different from what the industry's traditionally been used to. Instead of paying upfront with a monolithic appliance-based solution, what we're doing is subscription-based pricing, so that our customers only pay for exactly the ADC capabilities and scale and capacity that is being used in real time. So with that, let's get to question number 5. We covered the first 4 questions, so let's get into question number 5. And security is top of mind for all of us, and it's been a key feature set in load balancers and ADCs, for many, many years. But what we hear in talking to our customers that about 80 to 90% of these advanced features are just never used. And the one line we keep hearing is that if admins don't understand a system, they can't necessarily secure it. So Ashish, tell our friends, what are some of the reasons why, although there's been security features with ADC solutions out there, why have they not been actually enabled?
That's right, Didi. As you said, right, the 80% of the vulnerabilities are configuration related, misconfiguration, or not setting the right knobs. And the rest of them are volumetric attacks, such as DDoS or HTTP related attacks. And the primary reason that you ask why they are not enabled is because the admins don't know how these knobs work. They don't know if they turn it in a certain way, whether it's going to have a positive impact or a negative impact. So they're petrified into non-action. That complexity is the primary reason why people are not using the available features today.
Makes sense. So I think it's probably two big areas. One is there's vulnerabilities just by the ambient configuration, and then the second is spurious traffic that might be coming in from certain clients, which might be indicative of a volumetric attack. So what has Avi done, which is kind of different from the solutions in the industry? Tell us about this inspect, inform, and mitigate loop that we see here on this chart.
So Avi provides continuous security insights, or CSI as a short, and it consists of a closed loop system between inspect, inform, and mitigate. The first being inspect. We have an inline analytics engine. In addition to providing load balancing functionality, we continuously monitor the real-time traffic and analyze it, as well as we have a configuration analyzer for keeping track of outdated ciphers or new ciphers which might be available. So through the inspect module, we give you real-time feedback on and detection of what's going on in your environment, as well as whether your configuration is up to the mark or not.
And all of this is automated, so it's not like an admin has to log into each individual ADC device and figure out what's going on, right?
That's right. With the centralized controller, you get a centralized visibility of your environment.
Excellent. So fine. So we're inspecting all this traffic, the configuration, but how does the admin know that something is going wrong?
So after inspecting, we provide comprehensive mechanism to inform the admin in the form of a health score, which also consists of a security score by itself, which measures what the security detection, what the traffic is, what the configuration is, and we provide that ongoing feedback through health score, through security scores, through alerts, through events, as well as syslogs and so on. And that's how we provide this feedback to the admins.
Excellent. So we looked at inspect and inform, and then what are the different ways in which some of these attacks can be mitigated?
Right, so we can automate the mitigation through policy, or it can be manual. We provide you best ways to give you, to tell you how to mitigate this. You can rate limit the traffic, you can block the traffic, you can blacklist certain traffic, and also you can automatically update the ciphers, for example, when the new ones are available. So the whole closed loop system is automated in form of inspect, inform, and mitigate. And the fundamental problem that we are trying to solve is if you don't know what's going on, you cannot secure the system, and that's what we're trying to fix.
Great. So let's look at a real life example. I know what we're showing on this chart here on the left hand side is the archaic way in which ciphers, for instance, today have to be configured on every single device. Some of our systems engineers at Avi Networks have talked to more than 2,000 customers, and what they tell me is less than 3 of them have ever dared to change the cipher itself or even the order of the cipher in their history. So tell us, if you could show us how Avi has changed some of this archaic way of configuration that we talked about, that admins are just petrified into non-action. They just keep the default values and then never change it. So what are some of the innovations that Avi brings to the table?
Absolutely, and you're not surprised, right, when you see such a blob of configuration and you're told that disable the weak ciphers. Well, how do you even know what the weak ciphers are, what the impact of these ciphers is on security, on performance, and so on? So let me actually move to the live demo environment and show you some of these security configurations in action. So yeah, I'm logged into our controller in our demo lab, and for one of the applications, I'm going to show you what we can do. So let me go to the security profile, and here is the live example of what I was showing you in the slide. What we have is a real-time view of all the ciphers that you can select or deselect, And when you do that, we give you real-time feedback on what the impact is on your security, performance, and compatibility. For example, as I add or delete ciphers, the security scores gets updated. And what we're measuring here is not just security impact, whether something has a perfect forward secrecy, whether the ciphers are strong enough, but also the performance impact. For example, certain ciphers are more optimized for mobile devices, as well as compatibility. So certain ciphers are used by legacy devices, but the newer ciphers are only supported on the newer devices. So that real-time feedback is visible as you move ciphers around. You can drag and drop them around. You can select and deselect them, and you get a real-time feedback on your SSL rating.
Right. So I think the key thing is sort of this top right portion over here. You were giving real-time insight into when some ciphers are enabled, disabled, or moved. What does that do to overall security? How does that impact performance? And how does that impact compatibility across different browsers and devices?
That's right.
So the admins can take a much more meaningful action as opposed to just blindly changing
exactly
or not changing anything.
That's right.
So that's a great example. So tell us about another example of how Avi has made it simpler for some of the security admins. We heard about the POODLE attack from last year, and the fix for the POODLE attack was a simple thing, which was to disable SSL version v3. But I also know that 90% of the admins actually did not disable SSL v3. Can you tell us why they did not make any change? And then with some of these screens that you're showing us now with Avi Networks, how are they better informed to make a decision?
That's right. It goes to the same fundamental issue, which is if you don't know what the impact of your change is going to be, then you are not going to make that change. For example, if you use SSL v3, or if you want to disable SSL v3 to mitigate the POODLE attack, do you know how many of your users are using SSL v3? We provided that real-time insight. So on this pie chart, what we are showing you is what percentage of the users, in this case about 40% of them, are using SSL v3, and the rest are using some variants of TLS. What this tells you is that if I were to disable SSL v3, 40% of my users will be unable to, or likely unable to, use my site. That has a direct top-line impact on my revenue and on my business. This is the real reason why the admins are not going to, without this kind of visibility, going to disable SSL. With the visibility that Avi provides, it becomes much easier what the impact is going to be and how you can slowly disable by encouraging your users to move to the newer versions.
Makes sense.
This screen also shows you some other things, like, for example, how many users are using perfect forward secrecy, either in form of RSA certificates or elliptical curve certificates, and how many are not. And as you can see, about 50% are not. You can again fix that issues and encourage your users to move to a more secure perfect forward secrecy world. The SSL score that you see at the bottom of the left-hand side is, again, a real-time insights into the entire security configuration. It tells you whether you have perfect forward secrecy, whether you have SSL v3 support, in which case we ding your score, whether you have the right strength of ciphers, whether your certificates are about to expire or they are trusted or not. All of this is combined into a single security score, and then we present to you in a direct form.
So it's much simpler for the admins to make a change and know what that impact of the change is.
That's right. And this is real-time updated. So as the new vulnerabilities are discovered, we'll update the scores in real time.
Sounds great. So now let's look at question number 6. This is around multi-tenancy. And in talking to a lot of our customers, one of whom is the top 3 US retailer that we talked about, I think what the different lines of businesses are asking for in large enterprises like this is they want to be able to use the shared infrastructure that's put together either by the centralized IT team or by DevOps teams, etc. But different lines of businesses, based on the applications, they have different requirements. They want to be able to fire up their resources really quick, but at the same time, they don't want to suffer from a noisy neighbor problem.
That's right.
And I think all of this is geared towards just getting new applications out the door faster. So Ashish, let's start out by sharing with our friends some of the stories that you've heard from large customers as to how long it takes from the point an application developer wants an ADC to the time they actually are able to get there.
Believe it or not, it's about 4 weeks. So we have heard from a financial customer, and this is not common, this is not uncommon, that it takes, by the time the application developer requests a new ADC instance or a new VIP, to the time that the central IT can actually deliver that, it takes on an average 4 weeks.
Wow.
That's a long time of productivity loss, right? Today, in today's world of DevOps and self-service, you want to be able to deploy your applications much faster, and you want to do that in a ticketless fashion. Right. So that's the challenge that's today with the traditional ADC appliances, and the primary reason is again the complex configuration, and people are petrified into making any changes and affecting other higher SLA applications.
Right.
The way we have solved the problem is with architecture, with a centralized control plane and distributed per tenant data plane, where through the APIs, individual tenants can create their own ADCs without stepping on each other. And let me show you why that is possible with Avi and why it's not possible with the legacy appliances.
Okay.
So if you look at the evolution of ADCs over the last 10 to 15 years, the ADC started as hardware monolithic appliances where each appliance will have its both control plane and data plane and have hundreds of applications on a single appliance.
Right.
Now, as a result, these applications might belong to different tenants and they can step on each other. So for example, one application can hog all the CPU, either on the data plane or the control plane, and make the other applications less available.
Right.
You might ask, well, why not dedicate appliances per tenant? Well, it's very expensive because you can't really pool capacities between these discrete devices.
Right.
So what the evolution happened was to the virtual ADCs or the software ADCs. But the problem there is the fundamental architecture did not change.
Right.
Although software ADCs had a smaller footprint, you still had the combined monolithic control and data plane.
Right.
And again, to have better utilization of resources, you want to put multiple applications on virtual ADC, you run into the same problem.
Right.
With Avi, we have truly re-architected the ADC in a distributed data plane fashion. So you have a centralized controller and a per tenant dedicated data plane, in which you can dedicate micro ADCs per tenant. For example, a yellow, blue, and a green ADCs, set of ADCs for each of those tenants. And the tenants can now, in a self-service fashion, create their own load balancer instances or VIPs without creating tickets, without stepping on another tenant. So for example, think of an enterprise customer with three different tenants. Tenant one, for example, has the production application, a customer-facing application, which is mission critical, and they want full active HA and elastic scale. So as the traffic increases, your ADC resources are also increasing.
Okay.
They get their own set of SLAs with their own tenancy. Tenant B is an internal application, non-business critical. So they are okay with an active standby HA, and the scale is pretty much known, so you don't need an elastic scale. And in a development test environment where in their best effort, high availability, you don't really need a scale, where engineers can just fire up their own ADCs. All of these are possible with a single logical Avi Networks ADC. Why? Because of the built-in multi-tenancy. Each of these tenants, each of these business lines of will not impact each other as they create their own instances of applications.
So it's a complete separation in the data plane and a separation in the control plane, which was just not possible with some of the monolithic architectures that have existed in the industry.
That's right.
So to round this out, I think the differentiation comes from two aspects. One is the architecture itself. It's a SDN-like architecture with a separation of data plane and control plane. And then on top of that, I think our R&D team has been very pedantic about exposing every single feature with REST API.
That's right.
So it's 100% REST API support, so that it's not just multi-tenancy, but the tenants can themselves fire up their own ADC in 30 seconds or less.
That's right.
All right, so almost there. On this last one, we're going to talk about automation and integration. Different folks have different definitions for automation, but when it comes to Avi Networks, when we're talking about automation, I keep hearing the term lifecycle management and complete automation of lifecycle management. Ashish, what does that really mean?
What that means is that Avi, with the centralized controller, can automatically create, integrate with the rest of the environment, and scale on demand without human intervention.
Okay.
And the impact that has is accelerates time to application deployment. Again, time to value,
Right.
without increasing operational complexity and without driving operational expense. And the real reason why we can do that is because of, again, architecture. With a single point of control is also the single point of automation,
Right.
which is managing the entire life cycle.
Right.
Combine that with 100% APIs, you have a completely automated ADC. And
So I guess, the other point you're saying is like, with the legacy architectures, each ADC is an individual discrete device that needs to be managed individually. With Avi, it's a single point of control. It almost looks like a single device, right?
it is a single logical device, absolutely, as far as the control and management is concerned. So let's illustrate that a little bit more. So today, for example, with the legacy appliances, these are the steps that you have to carry out every time you have to create a new VIP or new application load balancer instance. You need to figure out what your backend, which networks your backend servers are connected to. Then you need to identify which of the ADCs that you have in your pool of appliances have capacity. Identify what network they need to be connected to be able to talk to your application. Manually configure each of those ADCs and plumb them into the network. Then provision your VIP with its own set of policies, with load balancer policies. And finally, configure the backend pool servers with its health monitoring and so on. Compare that to what Avi has done with its automation is automated almost all of these steps. And as a result, you get a 30-second load balancer creation experience. Why has Avi been able to do that? With its centralized controller, with 100% REST API-based integration with its ecosystem.
So this automation, looks like, for things like discover networks and backend servers, looks like, Avi already pulls this information out from a vCenter or from an OpenStack environment.
Let me actually show you that on a live demo. So let me go ahead and create a new load balancers and show you. As I do that, I'm going to walk you through each of the steps. So let me create a new load balancer instance.
You have 30 seconds to do that.
That's right. So I'm going to select my default clouds, which is vCenter. I don't want to do an OpenStack or AWS.
Okay.
Again, the point is that with a central controller, I can manage load balancer instances in AWS, in OpenStack, or in vCenter.
Okay.
Let's get it a name, and I'm going to call it Webinar Demo 2. And I'm going to give an IP address. In this case, again, I've automated my system through DNS. So I'm going to put a name, and it picks up the IP address through its automation, through its integration with the DNS system. I'm going to create an HTTPS for security reasons, and I'm going to pick up one of the certificates that's already available.
Okay.
Now I'm ready to configure the backend. Again, instead of typing it manually, we're going to the controller discovers what networks are available through vCenter.
Okay.
It's from that it pulls up all the list of all the VMs are on that vCenter. We're going to pick the Apache servers, add them. Remember, we didn't configure manually any of the IP addresses, and boom, we have a load balancer ready.
Wow.
So behind the back, what's happened is the Avi controller has talked to vCenter, not just to pull this information, but at this point to spin up a new VM if it needs to, plumb it in the right network, configure all the health monitor, configure all the backend server networking, and you have a VIP ready in 30 seconds.
And then how does it figure out where to instantiate the load balancer itself?
So it is smart about understanding where the applications are running, which servers they're running on. It takes care of application affinity. It takes care of HA to make sure that the two, if you're doing active-active HA, the two service engine VMs are not set up on the same host. It's smart about the entire lifecycle management.
So it's optimized for application performance. It's optimized for the best HA possible.
That's right.
Again, this is a manual task today that admins have to not only provision each of these load balancers, but also in a virtualized network, figure out exactly where to instantiate it. So now let's talk about, so we've talked about, a quick creation of a single ADC here. Now we know that any large enterprise is not going to have one ADC. They'll have dozens or hundreds. We even know customers that have more than 1,500 individual devices that need to be managed by ADC admins.
Right.
Now, with the new architecture that Avi has brought to the table, it's not just for automation, but also from an integration perspective, it's fundamentally simpler, right?
That's right. So if you see on the left-hand side of the legacy model, you have these discrete devices, hardware or software devices, that have to be individually integrated with your cloud management platform or your automation tools or any other orchestration device that you're using in your environment. Compare that to what Avi does with its centralized controller. You have a single logical ADC, which means single point of integration. So whether you have 10 applications or 10,000 applications, you are managing one logical appliance, which means you're integrating one appliance with whether a vCenter or OpenStack or AWS or your Chef Puppet tools or Cisco APIC or any other SDN controllers. That's the power of our architecture that not only does automation for a single ADC, but does automation at scale through this integration model.
Let's go back to the point you mentioned about the SDN controller. So let's say I was bringing in the Cisco APIC solution into my environment. Now I know that's a single SDN controller, and now I'm trying to integrate it with my legacy ADC infrastructure. Are you telling me that each of these devices needs to be individually configured,
provisioned in that a Cisco APIC or any other SDN controller, and managed? If you have an HA, you need to have 2 such active standby devices. And as you want to scale, as you add more physical appliances, you need to go back to your APIC controller, for example, and manually add each of them.
Right. And so with the Avi solution, then it's that single point of integration, a 1:1 relationship between an SDN controller and the Avi controller.
That's right.
And even if we add more capacity by virtue of these new service engines, it does not increase the complexity.
That's right. It's fully automated, right?
That's awesome. Okay, folks, so that completes our set of the 7 tough questions to ask your load balancer vendor. We blasted through a lot of material today around security, multi-tenancy, and integration, and then a couple of weeks back we recorded the other four virtues that we would love you to ask your load balancer vendor. Just to wrap things up here, we're Avi Networks. We've built a next-generation ADC solution, and that's really optimized for automation, self-service operations, and elastic scale. I would encourage you to go back and hear this webinar or hear the previous webinar, and then just come to our webpage. There's a free downloadable version of software at avinetworks.com that you can install or just play with in your environment. Thanks again for your time, Ashish, and thanks to everybody on this webinar. Until next time, here's goodbye.
Thank you.